Okay, let's start. Good afternoon, everybody. Nice to see you all. My name is Martijn Bosschaart from Salt Security. I am a technical channel enablement manager, which means as much as my daily job is about training and enabling partners and customers about Salt, and in particular, API security, because that's the space that we're in. And today we're going to talk a little bit about API posture and how to bring API posture actually into execution. But first of all, it's important to understand, okay, why do we need API security, right? Let me fix the laptop. Oh, sorry. There we go. And then the keyboard doesn't work. How's that for show? Now the video guys are going to be mad at me because we just changed all the settings so it would work on the screen, but now the keyboard works. So, okay, why API security? So why does Salt exist? Why did we build a company around API security in particular? And this all has to do with modern application development, right? If you look at applications today, and also what companies are trying to achieve, we're now building all these applications as cloud-native applications. So we're looking at breaking up monolithical applications into microservices architectures. Why do we do this? There's plenty of benefits, right? Easier development. I can cut up my application between developer teams. I can scale it independently. I can move it across infrastructure much more easily. So there's all sorts of reasons to do it, and those are very, very good reasons. But the thing is, there's also a couple of side effects. So first of all, the big thing that's going to change is my attack vector. My attack surface is going to change. Where we used to have these very monolithical apps that you could attack by going to a web server, we're now going to cut up the application into microservices, but each and every individual piece is accessible from the outside world. So we're opening up all these little pieces of business logic to the outside world, whereas, we used to be not so explosive with our apps. The second thing that is happening is there's another wave going. So the transition from traditional monolithical apps to cloud-native apps, that's been happening for the last 10 years or so. But there is this new wave coming, and this is the wave of generative AI actually being used as a development tool for applications. And this is where the problem lies. First of all, we all know the benefits of AI, right? So we're promised a lot of benefits like immense growth, etc., versatility, a lot of automation benefits, etc. But there's also another problem, and that's a cybersecurity risk. Because the big thing with AI is it learns from somebody, it learns from something, and that's us, humans, and we're still not faultless. That means whenever you're going to depend application development and code design on AI, you're probably going to incorporate a couple of the human flaws that we have. But it is an immense force driving the explosion of APIs that we see everywhere. If you ask Cloudflare about the number of APIs and the amount of traffic they see on the networks, almost 60% and upwards of all traffic currently going through the network is API generated. Right? So it's an immense amount of traffic. Because it becomes so easy to use AI, this is only going to grow and grow and grow. And I'm actually going to give you a live demo on how to build an API using AI. And then you will see how easy it is. Are there any developers in the room, by any chance? At the end of the next 5 minutes, everybody here is a developer. So easy, is it? So I'm going to show you how that works. So the first thing that we need is a tool you're all familiar with already, ChatGPT, right? So I've already put a little statement in my clipboard, and that says, "Hi ChatGPT, good day to you. First rule, always be friendly to AI. You know why? If the machines are going to take over the world, and they are going to turn against us, you might want to be friends with them, not enemies. So always be polite when you ask something, right? But the second thing is a very generic blanket statement. Please create an API for me in Python, very common language, that allows you to create a user and update the user information with some basic stuff. and I hit enter. There we go. So, good day. See, if you're friendly to the AI, they're friendly to you as well. It's going to live code the actual API for me. It's going to use a little tool called Flash together with some Python code that is now actually live assembling in front of my eyes. But I made a blanket statement. I didn't give much specifics, but it already is taking a lot of assumptions about what data I would like to manipulate, right? But the cool thing is, it tells me exactly how to create the API, what code I need, and it also tells me how to test it and how I can verify that the actual API works. And it actually delivers fully working code. But it does give me a couple of things. It says, yeah, you might want to expand it with validation, maybe some authentication, etc. That it hasn't provided, right? So it's a very generic piece of code. But let's see if it works. So I'm going to copy the code. And I'm going to just nano this into a little script. I'm going to save it, yes, enter, and I'm going to run it. And there it is. So my server is now running on the left with the actual application API code that I just created. That's it. So not much infrastructure needed. Now let's see if it actually works using the test commands. So we scroll down and let's create a user. Copy the code and just paste it in and run it. And there we go. User created successfully. User was created. You see the post, it actually turned an OK command. So that part works. Well, let's see what has it created. Let's check the user code. And there we go. Gets request, and it gives me all kinds of information. Oh, it decided to add an email address. Oh, I didn't ask it to write something in there with an email address, but the AI somehow decided that one of the parameters could be an email address. Also add an ID and a name, right? But this is not the problematic part, actually. You can expand on this very easily. So if you want to, for instance, go back and say, please add a MongoDB for permanent storage, it's happily going to tell me, okay, I got your API, and you just need to install this little command. And we're going to drop a database in your architecture. You just need a little modification to tell the actual script code how to use the database. But there's absolutely zero knowledge required. But there's also no verification of security standards, development policies, nothing of that sort. Congratulations, you're now all API developers, because this is all what it takes. Right? It takes you 3 to 4 minutes to build an actual working API that does run on a simple laptop, and you can use it. Of course, a developer might want to add additional security measures and all that stuff, but you can now understand that the actual growth of APIs and creating APIs is insanely accelerated. If these steps are already taken for you, you take the basic code, you're going to modify it. But it's all built with a standard that the AI decided on, not you. You can be more specific, but you have to take this into account, right? So this is the problem that AI is going to generate. It's making my job a lot easier, but I'm also going to be overwhelmed from a systems perspective of the number of APIs, and I don't know how they're performing, I don't know what functions is in them, because I didn't actually code the whole thing myself. So that is how you build an API with AI. That's how easy it is. Now, there's a lot of logos on this slide. You probably know what I'm getting at. These are all big companies. They have very big IT security budgets. They probably have every bit of cybersecurity equipment or software somewhere in their data centers around the world. But they all have something in common, is that last year, all these companies got in the news because of very, very big breaches. And all those breaches happened over the access of an API. Like T-Mobile was in the news twice, right? Fool me once, fool me twice, you know the little saying? Well, it happened. The thing there is, what happened is an exfiltration of 35 million customer records. 35 million customer records is not accidentally leaving a little text file on the file server with no security on it. That is a full data extraction where a database, middleware, and all sorts of application code had to accommodate that exfiltration of data, right? So something went wrong. But no alarm bells went off because these companies found out that they were being hacked when that whole database was sold on the Telegram channel. Anybody heard about the Ticketmaster hack recently over the access of Snowflake? When did everybody find out that the hack was taking place? because the data was already sold and exfiltrated. So how is that possible? How did these companies, with these very sophisticated application development teams, security teams, not find out that this was happening right under their noses? So there's a very, very big gap. And that gap is caused by 3 particular problem areas. And the first thing is simply having no API governance program in place. Companies have a very hard time knowing what APIs are they exposing. If they are exposing the API, what is its purpose? What risk is associated with the API? And what data am I actually sending over that API to the outside world? It's already very hard to catalog all the laptops and physical assets that they have, let alone knowing exactly how many APIs they have and what they all do. And then there's all the standards they have to adhere to. When you're in the financial world, PCI DSS compliance, GDPR compliance, PII data that's going out, GDPR and all that stuff. Do I actually meet those standards? And a lot of time, hacks happen because this part is not in order, because people simply don't know what they have, and if you don't know what you have, you can't protect it. That's how that works. The second part is that the current infrastructure measures that they've taken, security-wise, firewalls, API gateways, etc., are not up to the task to be able to catch API attacks. Because the problem with API attacks is that they're business logic and manipulations. They're not known bats, they're not code injections, they're not SQL injections, they're not log4j and that kind of thing, those kind of things. No, hackers are actually trying to use the APIs that you've built in a different way. They're not trying to find a bug in your code, they're trying to find a flaw in your thinking process. Can I use this API for a function that it was not designed for, but still use it in a legitimate way? That's a big problem. For instance, if you look at big data exfiltrations, this happens because there's an authorization problem in the backend somewhere. That means that an attack probably happened, and from a systems perspective, the user looks authenticated, right? Most of the API hacks actually happen because the user already had an account, or he's stolen an API key, so he looks authenticated. And then he executes a little bit of business code, and from a systems perspective, it looks like it is all fine. But a firewall, for instance, doesn't know that user A should not be able to access data from user B. It has no idea. It does not have the context. Same with an API gateway. What does an API gateway do? It protects access to the APIs. It does key management, it does schema validation, those kinds of things. But it has no actual understanding of the business logic. It doesn't know that an API is used to print a shipping label on a box and ship it. The business process is invisible to the actual technical implementation on the API gateway. And then there's the third part, and that is, if something happens, for us as an IT organization, it's very hard to react on. If I get hacked on an API, do I know? Do I get alerted? And if I get alerted, does the alert tell me who to route it to? Is this a problem with the code? Which developer is responsible for this API? So that ecosystem is not there, right? There is a lot of pillars, but the problem is that most of the time security tooling gets put into place is just another console that gives you just another alert. It's not part of a coherent ecosystem. So these 3 things need to be solved. Now, what do we then need to do to actually solve this problem? This is not solved overnight. There is no magical piece of equipment you can put into the data center and solve all your API security problems. You need to crawl, walk, and run. It is a strategy, right? It is not a product. Because it's a strategy, it means we need to get people into cooperating with each other. We need processes to work with each other, but also technology to work with each other. But it all starts with first knowing, okay, what do I have? So API security starts with a proper posture governance implementation. The first thing is discovery, knowing what you have. What kind of APIs do I have in my data center? What is in them? What kind of data is in motion, right? Where am I, for instance, responding with personal identifiable information? Do I even know where that is happening? This needs to be a continuous process, because you saw with AI just yet, it's very easy to create APIs, so everybody's constantly putting code live, so we don't need something that is based on a snapshot. We need to have something that is continuously looking at the actual stream of data, find the APIs, and keep on cataloging or updating that catalog. So it needs to be continuous. Now the second part then is actual posture management. We all want our developers to stick to certain rules and best practices and regulations, right? And we hope that they do this. But how do we actually enforce it? If somebody breaks a development rule, do we know? Do we know what the extent of breaking that rule is? And what do I need to do to see that he's breaking the rule and then actually making sure that he stops breaking the rules? So getting that into place is very, very important. API development rules are not only based on best practices, but there's also government regulations that dictate rules. For instance, if you are in the financial industry and you transact and you handle financial information such as credit cards or banking information, IBAN or whatever, there's a regulation somewhere in chapter 6 that says whenever you're responding with a credit card number or bank account, it needs to be masked. You will never be able to send this in the clear. It always needs to be masked. Well, developer can stick to the rule, but where are you actually going to see that this is being done? And what do you do to actually react to it? So that's the second part, the work part. So make sure that policy governance is in order. And then the third part, with all this knowledge, I can do something else, and that's threat protection. Can I actually now also see if somebody is attacking my business logic? Can I discover malicious user intent? And this is the most important part. Again, you're not looking for known bads when it comes to API security. You're looking for malicious user intent, and that's a completely different approach. The only way to actually do this is to baseline your APIs and determine, okay, what is good traffic? What do normal users do? So I need to baseline that traffic, and then I can find those deviations. But to find those and to really baseline that traffic, I need the help of AI and machine learning as well. Because the biggest problem with APIs is it's a lot of data. There's a lot of information in a request. There's a lot of information in a response. There's headers. Those headers have all different kinds of characteristics. They influence each other. We have the call sequences that are important. We have the frequency that is important. It's so much information to go through. Yeah, it's impossible for a human to actually find one little byte of a difference that could lead to an exploitation of data. What's also important is that that threat intelligence also needs to be consumable in other systems, like SIEM systems, source systems, logging and whatever. So it needs to be fed into that ecosystem. So this is the whole procedure if you want to do full API security. Crawl, walk, run, start with discovery, policy governance second, threat protection is the third one. Okay. If you want to split out this particular thing, there's actually two ways to go about it, right? So the first thing you need to do is build that API posture. And we start again with discovery. And we want to discover all API assets. This means we need to integrate with your actual infrastructure. We need to talk to the load balancers, the firewalls, API gateways, and actually see all that traffic. That's the first thing that we need to do. When we see all the traffic and now actually understand how those APIs are built, the second step is then to actually build rules around it. For instance, warn me whenever somebody is using personal identifiable information as a URL parameter. We can now see it because we've learned the APIs. This gets us gaps. There's going to be gaps in that infrastructure. But we need to remediate those. Right? Once we have the remediation in place, we also need to make sure that what we've done to remediate it is actually shared with those people that are responsible for building the APIs, so to make sure that it doesn't happen again. Right? So this is the first step. At no point in this entire track am I already talking about attackers. This is just to make sure that I prevent problems. So that's the first part. Now the second part is the threat protection. The threat protection does not work if I don't know what I have. So that is logical second step, right? There could be two things at play here using a threat actors. There could be problems with my API that I need to fix. There could also be just attackers that are annoying. They're not actually stealing data, but they're doing DDoS attacks or overloading my APIs or whatever. So there's two ways of responding. But I need to respond to the threat. That could either be sending a firewall command to block an IP address to get rid of an attacker or revoke an API key, or it could be creating a ticket telling the developer to fix an API because we see it has a flaw. Right? So there's two ways to remediate. Again, We need to see what those vulnerabilities are. We need to then remediate those. And once we've remediated those, we need to make sure that it doesn't happen again. And that's how you fully reduce the risks of having APIs. Now, how does that architecture look like? What do you need in terms of tools? Already told you in the beginning, we need data. We need to see data. We need to talk to the load balancers, the API gateways. We need to see all that API traffic and analyze it. So we need to baseline it. That means both the request and the response. A lot of traditional IT tools only look at incoming requests, see if they have a known bad, and if it's a known bad, we drop it. The problem is with most API attacks, however, is that the incoming request looks valid most of the time. It's the response that defines if it's a leak or not. That means that we need to see both the request and the response, right? That's why we need a bidirectional data feed. We feed all that into a data lake, and that's where the AI and the machine learning kicks in. That's where we do all the modeling, the baselining of all the APIs, and make sure that we get a good up-to-date catalog, an Active Directory with all your APIs, the inventory is up to date, all the data is classified, etc. That's the first step that then happens. Second step that then happens is that we can then create posture gaps and rules. We probably already created the posture gaps. That's what the developers did. Now we need to fix them. This is where the posture gap engine comes into place. So this is where I'm going to define all the rules. Maybe I want to define my own rules or use all the built-in rules depending on certain regulation that I need to follow. If I'm, for instance, in the medical world, HIPAA regulations have a lot of rules in them. Okay, we flick the switch and make sure that those rules are already in place, and we start checking our existing inventory. Do we match the regulation? Then we have threat actors that are happening, and we need to make sure that we gather all the intelligence as quickly as possible, because one big problem with API attacks is, why are they so big? Because the hacker had all the time in the world to do and perform the attack that he was doing. So we need to be quicker. We need to be quicker to find it. We need to be more complete with the information. Why is this an attack? And what to actually do to make that attack stop. This is all governed in the threat protection stuff. What's important is that we, again, don't overload the security team. So we don't want to be another tool that sends another alert. No, we want to be able to prioritize. So you immediately know what to focus on. What are my APIs that are the top risk? Which ones are the most under attack? What attacker is the most dangerous to me at this point? And help you prioritize. That's the architecture. And then finally, research. This is something that actually comes in from Salt itself. You will find a lot of articles published by our Salt Labs department that uncovers big breaches, such as recently in ChatGPT. We found that there were some serious security concerns when you were using plugins. We could actually, over the access of ChatGPT, exfiltrate personal identifiable information of certain companies offering plugins. And this is the research we do when we publicize it. It has already been fixed, of course. But that's what we also do. So look at the market and understand what kind of methods are hackers actually using. Now we're going to end the session with a little demo, and this is going to be the posture governance engine. So I don't have time to demo the whole product. If you want to see that, please visit me at our little booth after the session. But I'm going to give you a little bit of an idea what it is to create a posture rule and how to then react to it and do something. The posture rules that we have in the system, there's already a lot of them predefined, but you can create your own, and it's just simple logic. If a request has this kind of information and is sensitive, but it's not encrypted, I want an alert. Or if this particular field is a user ID, but it's not in the form of a full UUID, I want an alert. There's all sorts of logic. It's very easy to create, but it's based on the inventory. Here are a couple of other examples, for instance. External API response codes should only be 200, 404, and 301. There should never be something else, like a 500 server error or something, right? So we can actually look at all the responses that we've given over time, make sure that we're not overexposing information. Another thing is, no API request should contain API keys in the query strings. You'd be surprised how often that happens, or email addresses, or personal identifiable information as a query parameter. So these are all examples of rules that you can actually put into place. But let's just build one as a conclusion to the session. So here we go. This is the Salt GUI. This is the inventory page. And this system has already been connected up. It's been collecting data for quite a while now, and it already has a very extensive list and inventory of APIs. It shows you risk scores as well, so you know, is this an API that is at risk of maybe breaching, or it has a lot of sensitive data in it, etc. But you see all the endpoints. It will give you some other information as well, what kind of protocol is used, there's a traffic graph, etc. But below the covers, there's much more. Now, let me create a posture rule. What I would like to implement now is actually make sure that nobody is using personal identifiable information as a query parameter in a URL. Because that part of a request is not encrypted. Anybody can see it, right? The internet provider that you have that has a proxy, maybe, transparent proxy, will see that request and that email address is in there, or that API key is then visible. So we don't want our developers to actually accept that kind of information as a query parameter. That's a rule that we want to set. So let's do this. Let's create a new filter. So whenever a request is coming in, I'll make it a little bit bigger, and it uses a query parameter, and that query parameter is sensitive. So it's sensitive data. And then I'm going to add another condition, and I want to say that this particular sensitive data type is an email address, for instance. I don't want email addresses in my URLs, for instance. Now what you see, that actually, hey, one API triggered that particular rule. So one API is actually doing this. So it's actually allowing requests to be fulfilled with an email address in the request. That's not something that is according to my standards. So I want to put a rule into place. So what I'm going to do here is going to save this as a PostGap rule. I'm going to say this, no PIIs query param, please. Remediation, remove the parameter, move it to a body parameter, because that's a much better way of doing it, right? Because that is an encrypted payload, so that's not visible. Now, second thing that I need to do is give it a severity and a category. So what kind of category is this? Yeah, sorry, this is security standards and compliance. It's just a way of grouping particular rules within a PostGap rule. Now, I can save this, and what you will see now is if I move to PostGaps, if I reload, that always happens in the demo. There we go. Not logged in, there we go. Hey, I have one violation now. There's one critical rule. This API has actually violated this, so it now triggered an event on this. I get an alert on this. I can do something with it, right? So when I now click this particular rule, I have this view, and then I can immediately now say, okay, what's happening? What do I actually need to do to fix it? I have all the information and forensics about the endpoint, etc. Any labels. It could also show what kind of source. So how did this API got into my inventory? Who's managing it? But what can I also do is immediately integrate with a tool like Jira, create a ticket, and have that thing immediately sent to the developer right from this tool, right? So no time is wasted on this. And now we move into Jira, and there's my ticket already going to the right developer to have it fixed. This is a massive time saver, right? And this is the power of bringing that whole ecosystem actually together and making sure that this gets fixed. Now, this is also a two-way integration with Jira, so as soon as the developer fixes this, it will actually clear the ticket and also clear the alert. But there might be more stuff going on, right? So let me go back to Salt here. Because we have a lot of rules in here, so there's already a lot of pre-built rules. But give you another couple of examples. I'll turn a couple of on. This one on, this one on, this one on, this one on, so I can make it a little bit interesting. Yeah, you see the numbers already go up. So we now have a lot more of policy rules here, but a very important one here. I have one here that is sensitive data is exposed without authentication. So we actually see a request coming in and a response that has parameters in it that are classified as sensitive data, but it doesn't check for authentication. That means that anybody that's external and knows that particular endpoint URL can go and grab data. And if he doesn't need to be authenticated and sends a valid request, what's the response going to be? 200 OK. What is not going to happen is that you're going to see that this is happening. Because nobody is getting alerted on a 200 OK. So this rule we can now put into place and again open a ticket and tell the developer, you might want to do something about that authentication check here. Right? So this is how, again, that works. So you see that there's a lot of PII data in here, customer last names, cities, and all sorts of stuff. There's some other rules as well here. For instance, tokens that don't expire, or sensitive data. Again, in the URL, there was already a rule like this, but pretty much any type of rule can be done. And we also have all these different categories, like GDPR, HIPAA, OAuth specific, PCI DSS, personal identifiable information. So you can actually turn a whole category on at once, or group them within a certain category, and make sure that you follow up on these rules. This is the way that you can actually get a grip on how APIs are actually being deployed, especially when you see that development going so much faster these days, right? So, having said that, a couple of final points on the whole thing is, again, what's important to understand here, what I would like to have you take with you is, understand that API security is a very different problem than the traditional infrastructure problems and security problems that we've been fighting, right? API security is not a product, it is a strategy. You need to bring certain systems together, people together, etc. But it's also a three-pillar problem. And it starts with posture governance. If you don't know what you have, if you don't know what the risk is associated with the APIs, you are setting yourself up for failure, right? So make sure that that step is present. That's always the first step you need to do when it comes to API security. And also be aware that the traditional infrastructure components that you have, they might say in the brochure, yeah, we do API security too, but look a little bit deeper. It's normally nothing more than a little bit of SQL injection, DDoS protection, those kinds of things. Advanced business logic attacks cannot be stopped by an API gateway or a firewall. They pass right through as valid traffic. So please look into this as well. And then finally, make sure that you bring that ecosystem together. The first thing that Salt does is give you a lot of information, but we don't replace any systems that you already have, right? This is not your new API gateway. This is not your new SIEM system. We work by bringing these together, get the telemetry from the API gateway, build the threat intelligence around your APIs, and feed that into your SIEM. That's our purpose. So it brings everything together. So we're at the end now. I'm at the end of my presentation. I'm happy to take a couple of questions if you have them. If you want to see a little bit more, I can of course show you attacker detection, all that stuff. We have a little booth. It's easy recognizable. It's the only one that doesn't have a banner because we forgot it. So that's the easy part. So at this point, any questions that you might have? Yes, please. The question is, how do you bring in information from SaaS applications? Those are very good questions. It depends on where the SaaS application is running. So what this solution does, it focuses on the party that actually creates and hosts the API themselves. This is not, for instance, for a situation where you use an external API, because then you would only be able to see your own traffic and not all the traffic comes in. So that's a good positioning point. So if you would, for instance, say, hey, we have this SaaS provider that we work with, we want to make sure that those API calls are safe, please introduce us to that SaaS provider, because that's the party we want to talk to. Because we should be at that part, so where the actual API is hosted, executed, and created. Yeah, but good question, thank you. Anybody else? Was it that clear? Perfect. Okay, thank you very much, have a good lunch, and we'll see you at the booth then.